Werewolves are cool. I can pretend it's for some deep reason, like it represents the savage beast in man we've actively repressed for 10,000 years of civilization. But nah, I've always loved them. I mean, they're pretty much fluffy versions of the Incredible Hulk. A good boy banner, if you will. They might slaughter your whole family, but how can you be mad at that face? Nowadays, werewolves are starting to get the recognition they deserve.
I don't want to be a vampire anymore, I want to be a werewolf.
They come in all different shapes and sizes. Some more wolf, some more man, and some even like golem. All equally sexy. But the one thing that ties them together is their relationship with the moon. But why is that? Why does the full moon cause these infamous transformations? Are they forced to change, or are they just more active? What makes a full moon different from any other night, and what changes could it cause? After testing a variety of hypotheses, I may have found a scientific explanation. Let's go through them all together to see what does or does not work. Let's start with possible reasons in physics, because it is the theory of everything after all. Could the full moon trigger a unique physical reaction that could change a man into a wolf? Every interaction in this universe is caused by one of these four fundamental forces, but the moon and you are in quite a long distant relationship, so you can only communicate through these two. Light is electromagnetic radiation, and the most obvious cue of a full moon is its moonlight. During the full moon, the moon shines brighter than any other night, and light is an important catalyst in many chemical reactions. Biologically, one of the most important would be photosynthesis within plants. This is where primarily red and blue wavelengths are absorbed by chloroplasts and then converted into chemical energy for the plant. So is there a unique wavelength hidden in the full moon's light that could trigger some process for werewolves? Well, the term moonlight is a little misleading. The moon doesn't actually produce any light. Instead, it just reflects the light from our sun. So the moon works as a mirror, but not a perfect one. It can only reflect a small fraction of the sun's light. One half of the moon is always lit up by the sun, constantly reflecting the same amount of light. As the moon transitions through its phases, that lit side of the moon becomes more or less visible to Earth, reflecting different amounts of light to us depending on how much of that lit surface faces our direction. When the moon is new, we see none of the lit side. When the moon is in its first or third quarter, we can see half, and when the moon is full, we can see the entire bright side of the moon. So what is the difference in the light from the full moon compared to the other phases? Well, the light itself is the same each night. That is to say, the wavelengths of the light remain consistent. The only difference is how much of that light is reflected to us, or its intensity over the month. The full moon is the brightest moon, reflecting the most amount of light and having the highest light intensity out of all the moon's phases. So there aren't any unique wavelengths in the full moon. But perhaps our lycanthropic curse only responds when wavelengths of this specific light reach a certain intensity. That would explain why only the full moon triggers this transformation. However, you might have already noticed the flaw in this theory by now. The light from the moon is the same light during all its phases, but it's also the exact same light that comes from our sun. They share the same wavelengths, of course, but without the imperfect reflection from the moon, the sun's direct light has a significantly higher intensity, approximately 1 million times greater. Therefore, the full moon's light offers no unique wavelength, nor any wavelength of greater intensity than daylight. If werewolves were actually responding to the full moon's light, then there's no reason normal daylight wouldn't do the same. On to gravity, the force responsible for the attraction between two bodies of mass. Our moon is constantly pulling on us as we pull back on it, but thankfully Earth's own gravity keeps our own 2 feet on the ground. However, the effects of another celestial body so close to our planet don't go unnoticed. The moon's gravity is responsible for our tides. Well, to be precise, 2/3 of them. That other third is caused by our sun, which also pulls water towards itself. Tidal forces can be a tricky topic to explain, even more so when it has to be just a subtopic in a werewolf video, so here's a crash course. So the moon pulls on the Earth with a gravitational force of F, where r is the distance between the moon and the Earth. The force gets smaller as the distance increases. So if we look at the force diagram of our Earth, the surface nearest to the moon has the greatest pull because it's the closest. The center of our planet receives less of a pull, and the far side receives the least. But we, the observers on the planet, see and feel from its perspective. So if you want to match our force to the Earth's, it looks like this, with 2 equally strong forces, one near the moon and one opposite. You can replicate this exact effect by using highly advanced scientific equipment, such as a rubber band. Here we have our Earth stapled to the center, just like in real life, but I've marked my edges underneath so we can see how far it stretches. Now, my right hand is playing the part of the moon, so when I pull it, it represents the moon pulling our Earth with gravity. You can see the edge closest to the moon travels the most, and the edge opposite travels far less. However, if you measure from the Earth's perspective, both sides have been equally displaced. It doesn't matter which side the moon is on, both sides of the Earth experience 2 equally strong pulls. Since the Earth rotates once a day, we can guarantee 2 high tides, one when the moon is overhead and the other when it is directly behind us. In order to see this phenomenon without a rubber band, you need a large amount of a free-moving substance, and that's where our oceans come in. The moon causes the ocean to rise an average of 6 to 10 feet during high tide. But how come our lakes don't? Both are water, and since everything around you is an equal distance from the moon and is experiencing the same acceleration, why doesn't everything else just rise that much? Unfortunately, the moon isn't strong enough to just lift the ocean 10 feet higher. The most important part of the ocean is that it is free moving, covering enough surface area that different parts of the substance would have significantly different forces. So small tugs by gravity build up and pull water away from areas with little or no pull. The water follows and collects in those gravity swells, and that's why we experience the tides. Even super tiny forces can have drastic changes once they are multiplied by the length of the Earth's radius. You can think of it as, for every meter traveled, a single water drop is pulled. In a distance of a few meters, nothing really happens. But once you travel a few billion, you can get a wave. But what I've described so far is the moon's normal gravity throughout the month. During a full moon, the sun's gravity aligns with the moon's and gives our tides an additional boost. Could that boost in gravitational force be enough to trigger a werewolf transformation? Sadly no, because the full moon has essentially the exact same gravitational effect on our planet as the new moon, because the tides are equal and opposite on both sides of the planet. If it did, werewolves would be turning twice a month rather than just once. Also, it's worth mentioning that the change in gravitational force is extremely small, but don't take it from me, listen to someone who has actually finished their doctorate.
The moon creates a tidal force across your skull. Okay?
I did not know that.
Yes.
And-
Across anything.
Right.
This side of your head is closer to the moon than this side of your head.
Okay.
But we can calculate what that difference in gravity is across your head.
Really?
It's not very much. So you can calculate how much that is, and then you can compare it to other things that are operating on your head. Like you go to sleep, and there's a pillow sitting right here.
Right.
The weight of the pillow to distort your skull is about 1 trillion times stronger than the tidal force of the moon's gravity across your skull. But no one creates whole mystical predictions about
what your pillow's going to do.
What brand of pillow you slept with last night. Yeah, so there are very strong ways you can demonstrate that really there's no effect on people, other than the effect you think it's supposed to have.
Right.
You come out of the bar at 2 in the morning,
Right.
full moon is up. Oh, it's a full moon.
Right. I'm going crazy. It has
go
nothing to do with all that Jack Daniels in there.
Neil leads me into my next hypothesis. What if the effect is psychological? A large portion of the population believe that people act crazier under the full moon, including the majority of health professionals. I mean, the word lunacy literally is named for the Latin word for moon, luna. If normal humans go insane under it, perhaps our typically well-mannered werewolves also lose control. Well, my response to this idea of lunacy is that people are crazy, just equally throughout the month. There have been many studies done on the subject, my favorite being Roten and Kelly's 1985 Much Ado About the Full Moon. The study combined the data of 37 separate studies, which included the detailed records of lunatic behavior, including factors such as mental hospital admissions, psychiatric disturbances, crisis calls, homicides, and other criminal offenses. Even true measures of human insanity like the Dow Jones were recorded, and they found no significant relationship between the full moon and people. Studies that originally reported a lunar effect were found to be flawed, like Temple 1982, which found traffic accidents to be more common under the full moon. When Rotten and Kelly went through the data, they found the majority of the full moons were on weekends. When using the average amount per weekend instead of average day, the lunar effect disappeared as well. The authors hoped this would bid much ado to this moon misconception. But 38 years later, people still believe it, so scientists continue to study it. One recent study even had 18,000 cases of psychiatric patients, and found the full moon had no relationship between admissions, discharges, or durations of stay. This large amount of research suggests that we shouldn't believe werewolves would act any different under the full moon either. So things didn't work out on the human side, but werewolves are 50% wolf, so how do they react to the full moon? You've probably heard that wolves howl at the moon, but that's a myth. Wolves are generally more active at night and do howl in an upward direction, but that doesn't mean it has anything to do with the moon. Wolves actually howl in an upward direction because it helps the sound propagate further, and howl at night when the moon is out because they hunt at night and need to communicate with their pack. But even if wolves aren't howling because of the moon, it's been believed that they are generally more active and therefore hunt and howl more under the full moon. And this is where things start to get interesting, as studies have shown not only is this not true, it's the exact opposite. One study showed wolves to be almost 30% less active on the full moon as compared to the new moon, traveling about 2 kilometers less on these brighter nights. This is consistent with other studies showing that in general both predators and prey species are significantly less active under the full moon. This is because both predators and prey use the cover of darkness to their advantage. The predators use it to sneak up on the prey, and the prey use it to sneak past the predators. When you flip on the lights, this never-ending game of stealth is essentially in a timeout. Both sides can easily see each other, and they wait out this monthly Mexican standoff until both regain their advantage. So if our werewolves really took inspiration from their animal side, they'd most likely stay in on those nights and relax. It would be the safest time of the month from them. At this point, things were looking pretty dire, and not in the good way. Nothing in physics, human psychology, or predator behavior could give any substance to this myth. But when I made a vow to join Team Jacob, I did it for life. So I pushed on and got a bit more creative with exploring animal precedents and found an answer. When things seem too alien to exist, chances are you aren't looking beneath the waves. The moon and the ocean have had a long relationship with each other, so it makes sense that marine life would adapt to the lunar cycle, but just not for hunting. When animals do something that makes no logical sense, it's usually for reproduction. Have any species decided that a full moon is just as romantic as a candlelit dinner? The answer is yes. Once a year, there is a mass spawning of coral, usually a day or so after a full moon. This coincidence was just too much for some researchers, who wanted to find the exact trigger for this phenomenon. And what they discovered was it wasn't the light of the full moon, but the lack of it. In particular, when there was about 1 hour of darkness between sunset and moonrise, the coral would start to spawn. They tested this by essentially placing a blanket over the coral for different periods of time, which is just a great example of how groundbreaking experiments don't have to be overly complex. But with the changing of the sunset and moonrise times across the year, this specific time frame is annual at best. However, it does set a precedent for a full moon being the trigger for an animal's reproductive cycle. Thankfully, we have jellyfish to offer us a monthly example. For every single lunar cycle since 1994, people have noticed groups of 500 box jellyfish gathering to breed 8 or 12 days after the full moon, which is some pretty good organizational skills for animals that literally don't have a brain. Once again, the trigger was not moonlight, but its absence. This time, whenever there is extended darkness between the sunset and moonrise, in the time frame of 4 to 8 hours. So, while the full moon usually suppresses hunting, it could be a valid behavioral trigger in a werewolf's reproductive cycle. These two examples make a case that it wouldn't be absurd for an animal to breed under the full moon alone. And since werewolves essentially reproduce by biting a human and allowing them to survive, werewolf attack stories and those who live to tell the tale would follow a lunar cycle. This idea has some interesting modern implications, as the constant light in our modern world would desynchronize our werewolf cycle, as it did with the coral. This could delay or even halt the werewolf's instinctive urges and be why stories of them became a relic of the past. I'd personally love a good werewolf story from a scientific perspective, so I hope a few of my writer viewers get some inspiration. But what do you think of this theory? Let me know in your comments below, and please make sure to like and subscribe because if I was a werewolf, it would certainly make my tail wag.